Добрий день všetkým. Volám sa Alexej a pracujem v spoločnosti Dell Technologies. Som začínal v IT veľmi dávno, pre mňa celý môj IT, celý môj profesionálny život. Začínal som ako Oracle administrátor, potom pracoval ako project manager a momentálne už 8 rokov fungujem v firme Dell ako špecialist na hardware. Pomáham v podstate firmám vyberať ten správny hardware pre používateľov, pre vás a som veľký fanúšik AI, používam LLM na dennej báze aj v práci, aj doma. A dnes budeme hovoriť o hardware pre lokálnu umelú inteligenciu. Po slovensky sa ešte učím, takže pre rýchlosť teraz pripnem do angličtiny. Let's get started. So, I want to start with these two pictures, and on picture one you can see back in the year 2016, CEO of NVIDIA is passing this big box, which is specially designed hardware server from NVIDIA to Elon Musk. At that time, Elon Musk was co-founder of OpenAI, and OpenAI told that this hardware helped them speed up development and make more iterations. On the second picture, you see what we have now on our stand also, but from Dell. It is the same device like from NVIDIA. It is a very small box, size of micro PC, which can be used for local AI development, local AI fine-tuning, and also inferencing. And you see the difference between these two boxes are very huge, especially in terms of price. Now, everyone can buy, or even small company can buy this device with price around $4K US dollars. And it can provide almost the same performance with 128 gigabyte of memory and special architecture, and I will tell about it a little bit more in the next slide. So basically, this device, which is called Dell Pro Max with GB10, is both unique and not unique because you can find in the market hardware systems for AI development. You can find cloud solutions. There is a DGX Cloud AI training platform from NVIDIA. There are servers with liquid cooling and tens of super powerful GPU from NVIDIA and ARM-based CPUs, of course. But these super high-end systems are extremely expensive, and they are difficult to come by and very difficult to get resources from these systems. And as a developers, you need to start to experiment to tune now. And also, I would say that there are a few challenges connected to AI development, like which toolset, which SDK should you really use, which platform or cloud platform you should use. If you are developing on a normal, regular PC, or workstation, you may run into performance problem very soon because of GPU limitations. And of course, you can use more powerful solution like desktop workstation with 4 graphical cards, but cost and size of the system will be really big. Some users have access to data center service, but you are not first in the row normally here. And if you are talking about AI development in the cloud, which is an obvious choice, you always should think about compromises like how much will it cost you to train model 10 times, 20 times, 50 times. So it is unpredictable bill, unpredictable cost. And in terms of security, if you put your sensitive data into the cloud, it's not your data anymore. Of course, there is also legislation restrictions, and some data like card data, personal data, medical data just cannot be put into the cloud. So, if I can tell you that now you have the opportunity to use local inference and local LLM just at your desk, and you can have your data local, under control, and you can play with the model and the size of the model with a Swiss purposely built device, and we can speed up your development very much in this. And best of all is that this small purpose-built device has also a very comprehensive software stack from NVIDIA, so you can start like this. If you are talking about AI development lifecycle, of course, it is start from step 1, which is develop your objectives, use cases, strategies, then you prepare your data, you do data management, but then you do many, many iterations. You need to choose the right model, you need to evaluate them, you need to train them. And there is no some guideline or some decision tree, which model should you choose for your task, for your business case, you need to experiment. And even if you even know that, okay, I will use the latest Llama 3.1 model, there are many flavors of this model in terms of size, in terms of number of parameters, in terms of like version, etc., etc. But if you have the opportunity to try different models locally on your device, you can speed up your development very, very much. Actually, I want to tell you that we have a local stand, and you can try it by yourself. I mean, this box, this Dell Pro Max with GB10, and this is the first system in the market which have architecture which before then NVIDIA provide only for data centers. It is NVIDIA Grace Blackwell architecture, and in terms of performance, it can provide up to 1 petaflop with precision FP4 and supports a model size up to 200 billion parameters. And in the memory size, you have unified memory, and this unified memory is 128 gigabyte. Let's take a look at the ports. You have find like standard ports here, USB-C, HDMI, Ethernet, then 10 gigabit for normal connection. But what is stand out, you have also a QSFP port. QSFP port is a port you normally found in the data center server for speed connection between servers. And by usage of this port, which has throughput 200 gigabit, you can stack two devices together, and in this way you can double the performance of your device. There are two deployment options for this device. One we have at our stand now, when we have directly connected keyboard and monitor to the device, and you also can use it like network connected when you use it for several users or small group of users at the same time. And now I want to show you a short demo, how it looks. I will show you the screen, I will show you dashboard, and I will show you 120 billion parameter model, how it runs on the device. Okay. It is how look the screen, it's standard Ubuntu screen. There is a very comprehensive guide from NVIDIA. You can click on the site, build.nvidia.com, and you can see step-by-step instructions how to start to work with this operation system. And you can see like in the tools, there is a DGX dashboard for monitoring. And also I installed Visual Studio here and NVIDIA AI Workbench. And now what we're going to do is to start dashboard. You see memory usage. It's pretty low, and GPU utilization on this dynamic side. Now I'm running Docker container and run local model. And then I'm going to start open the API locally with a model OSS GPT 120 billion parameters from Llama. So, you see I am starting open WebUI now. And now I want to turn off my Wi-Fi connection. And there is no wired internet connection to the system, so now we are doing totally offline, locally on the device itself. So I'm signing in. And for the first run, the model needs to put itself in a cache, and there is like some time you need to warm up. That's why when I start typing and entering my first query, it will take much longer time to execute, and second query would be 10 times faster. Now, when I enter the query, you will see the change in the memory utilization first, when the model is going to the memory, operation memory of the system. And next step, we will see the spike in the GPU utilization, but it will be later when models start to generate tokens actually for an answer. So you see now our memory for this size of model, 120 billion parameters up to 70 gigabyte. And we see some minor spike in GPU utilization. And then when we go for the real token generation, it would be almost 100%. It is the most hard task for the system, for hardware at the moment. Now model started generated an answer. For the first run, it took me for this question 21 seconds to think. And I limit the answer to 600 symbols to make it short. And now we see there are still usage of GPU because model is now trying to propose follow-up questions. It is normally done by ChatGPT or Gemini or this type of cloud models. And now I'm picking up some follow-up questions. You can see GPU utilization down. And after follow-up, it now again up. And now it's thought for 2 seconds and started generate tokens for an answer. Okay. Basically, that's it for this short part of the demo. And I also wanted to show you how to start with it with help of NVIDIA portal. Okay. Now I am on the page buildnvidia.com/spark, and to be honest with you, I am not like NVIDIA administrator, not a Linux administrator, not a developer for many, many years. But it was really easy even for me to set up these models and be up and running because of this perfect portal NVIDIA built. When you want to start, you can some quick starts workbooks from NVIDIA. And if you open, for example, this, like OpenWebUI, you see overview, what is the basic idea about this setup. And there are 2 options how to set up with NVIDIA utility or manually. When you go for manual setup, there is a very comprehensive step-by-step guide how to do it in a bash, right? And also how to do troubleshooting and next steps and how clean up and roll back. So there are many playbooks available and they are coming new from NVIDIA. So basically you can experiment with all these workbooks, like with microservices from NIM, with multimodal chatbot, with some image generation, and even vibe coding with Visual Studio, with local model. Okay, talking about software, together with this super PC, NVIDIA provides some stack of software. Some of these pieces of software is pre-configured. Some you need to download. So basically, we have here first level is a hardware part where we have CPU, GPU, acceleration blocks. Then next level you have DGX OS system software with pre-configured drivers and containers. And also there are on the next level acceleration libraries for AI. Like CUDA, etc. And next level is SDKs, frameworks, like also there are domain stakes to work like Riva for conversational AI, Holoscan for sensor processing, Metropolis for vision AI application platform. And next level is basically the highest level with blueprints and workbench. And a lot of people in my daily work ask about model size, what is like maximum model size to run on a local device. And here you can see on this slide rough estimation like hardware and model size. Model size we define in the parameters, like for model with from 6 to 30 billion parameters, you can use normal slim form factor workstation with, of course, a discrete GPU, but your video memory should be up to 20 gigabytes. So next level up is more powerful workstation with GPU memory up to 96 gigabytes. And next here comes this small box, basically, which is very comparable, and 2 boxes. And now basically we go for data center class solutions, which are really big, very expensive, and it's a different level of power for running local models, basically. So I think that from my experience, I played with this super PC, supercomputer for maybe 2 weeks, and I read many articles about it, so many YouTube videos with reviews, where more professional people and developers tested it, and what they're telling is that it is not like super computer in terms of speed, but it's like a Swiss Army knife, which gives you flexibility and opportunity to experiment, to play with it, to try different models, to try different approaches, and then you can go to production really, really fast. And what is also maybe important thing is that NVIDIA software stack and NVIDIA GPUs now de facto standard for data center. And when you start to use this stack of software solutions, you can easily scale up, and you can then make your ready application and put it in a data center. So basically, you start with a bigger size model, then you fine-tune it, then you quantify it, you make like smaller model of it, ready for development, and then you can deploy your model in your production environment, and you can continue to play. Also, additional use case or target group for these kind of devices I see is that in our region, let's say in Central Eastern Europe, many universities is buying this device for their students to experiment. And also, it can be used and we also have successful pilots in Slovakia, where people just used REG, and they put their data in a model, and they use for very sensitive data in a closed environment this solution, and it works for them pretty well. Basically, it's it from my side, so we can start questions if there are any. And also I provide you some QR codes for this starting page from NVIDIA, and some maybe additional information from a Dell side. What kind of devices is it, how much is it, what is the configuration and the stuff.